Okay, now welcome, and so we are going to start talking about our next topic, which is damped trigonometric graphs. So we're going to start by using this function on the board here as an example. So we've got a product of two functions actually. So if we look at this as f of, well, let's do this. Let's say g of x is equal to x and h of x is equal to sine x. So we got a product of two functions. And so we can know the behavior of this function here, f of x, by looking at the properties of the individual functions, g of x and h of x. Okay? And so actually what we're going to do is we're going to look at the properties of absolute value, and we're also going to look at the fact that what we know is sine x is between 0 and, 1 and negative 1. Okay? So let's look at the absolute value of these functions. Okay? So if we take the absolute value of these functions, so we'll take the absolute value of x times the absolute value of sine x. Okay? Well, we know that that's going to be between what? Well, x can go off to negative infinity, right? It goes off to positive infinity, right? But sine x is going to bounce between 0 and 1. Okay? And of course, another way to see that, so if we look at this here, this is going to be 0 to 1, so this is going to go from the absolute value of x to 0. Okay? But also, if you think about it here, another way to look at it is we know the absolute value of sine x is between 0 and 1. Of course, if we multiply all three pieces of the inequality here by the absolute value of x, we get this. Okay? So we know that, right? Now, if we take away the absolute values, right? Well, that means that what's going to happen here is this is going to equal what? The negative absolute value of x less than or equal to x sine x is less than or equal to the absolute value of x. Okay? And so what this means is this graph is going to bounce between what? It's going to bounce between y equals x and y equals negative x. So it's going to be between those two lines. Okay? Now, also, realize that this function is either going to equal x or negative x when? At every odd multiple of pi over 2. Right? Because think about this. Sine x, right? So sine x equals 1 or negative 1 when x is what? When x equals pi over 2 plus or minus, well, plus, because n is an integer, right? So pi over 2 plus n times pi. Okay, so in that case, what does that tell us? It means that this here is going to equal plus or minus x whenever x is equal to pi over 2 plus n times pi, right, for n, for any integer n. Okay, now another thing also is this is going to be equal to 0, so it's going to have an x-intercept when? Well, when what? Sine x is 0. And so when is sine x equal to 0? Well, sine x is equal to 0 for any multiple of pi. Right? When x equals any multiple of pi. So that means x times sine x is going to equal 0 for any multiple of pi. Right? So it's going to be 0. So it's going to be an x-intercept whenever x is equal to some multiple of pi where n is an integer. And so x is called, so here's where we get, so x here is referred to as the dampening factor. Or damping. I should say not dampening. It's called the damping. The damping factor. Okay, and so the graph is going to look something like this. Okay, so if we have our y equals x, we have that, and then we have y equals negative x, which is going to look like that. And then what happens is our sine function is going to be squeezed behind those. So it's going to look something like this, right? So it's going to look like that. Okay, so where the graph is going to bounce between y equals x and y equals negative x, and it's going to touch the either one of those lines at odd multiples of pi over 2, right? And then it's going to have an x-intercept at every multiple of pi. Okay, and I think that's it. That's all I want to say. So that is an introduction to a damped trigonometric graph. Okay, so now we're going to do another couple examples and we'll move on.